see it now?
Perfect.
Okay, thank you. So good afternoon to everyone. I'm America Califano, a postdoc researcher from University of Salerno. And today I'm showing some results about the experimental investigation about the fatigue crack growth behavior in stainless steel specimens obtained by additive manufacturing. We all know that additive manufacturing techniques, and in particular laser powder bed fusion techniques, have a high potential because they allow to produce any kind of complex shape. But however, the performance of the obtained components and materials are influenced by many factors like the presence of residual stress fields, the presence of porosities, the crack orientation, or different environmental conditions. For this reason, there's the need to deepen the knowledge about the influence that these factors have on the performance of the material, and the need of deepening the knowledge about the fatigue behavior and the crack propagation in additive manufacturing materials. So in this framework, the aim of this work is investigating the effect of crack orientation on the fatigue life of 17.4 pH stainless steel specimens. And the activities are based on some main steps that you can see here in the slide. So first of all, there's the manufacturing of plates by means of selective laser melting technique. Then compact tension specimens are extrapolated from the plates and prepared. In particular, they are equipped and instrumented. Then some analysis of the microstructures are carried out, and finally some experimental crack propagation tests are carried out as well. So the first phase is the printing phase, and here on the right you can see a list of the printing parameters and a picture of the powder that has been used. And after the printing phase, a rectangular plate was manufactured with a thickness of 8 millimeters. Then the plate was milled in order to obtain a thickness of about 6.75 millimeters. And then the plate was finally grinded, and a final thickness of 6.75 millimeters was obtained. So here you can see a schematic of the final plate with the measures with dimensions in millimeters and the final thickness of 6.75 millimeters. From the plate, 10 specimens were extracted by EDM, and here you can see even a schematic of the specimens. So you can see that there are 9 compact tension specimens and 1 additional specimen. This 1 additional specimen was used for carrying out metallographic analysis. Then the other CT specimens were used in this way. 1 specimen was used for setting up the testing machine. Then 4 specimens were used for carrying out fatigue crack growth experiments in air, while the remaining 4 specimens will be used in near future for carrying out the same experiments, but in a corrosive environment. And you can see how the different CT specimens are characterized by different crack orientation. In this work, I will show you the results for specimen number 2 and specimen number 5 that are characterized by different crack orientation. So the specimen number 2 has an horizontal crack, while specimen number 5 has a vertical crack. So considering specimen number 10, the one that was used for metallographic analysis, we can take a look at the macrostructure of the material. And here there is a schematic of the plate, and the building direction has been highlighted. The building direction was parallel to direction Z. As a matter of fact, if we take a look at the Y, Z, and XZ planes, we can see how as these planes are along the building direction, the grains are longer and slender if compared, for example, to the other plane, the XY plane, in which this kind of behavior is not noticeable due to the fact that the XY plane was the base plane for the printing phase, while the Z direction was the building direction used during the printing phase. So the specimens were extracted by from the plate. They are CT specimens, and you can see here schematic of the specimens with all the dimensions in millimeters. And you can even see a schematic of a CT specimen equipped with a back face strain gauge and 2 crack gauges. The 2 crack gauges had 20 filaments each, with a distance of 0.254 millimeters between 2 successive filaments. The CT specimens were subjected to tension fatigue tests with a maximum applied load of 4,500 newtons and a pre-crack of about 1.3 millimeters. Here on the right, you can even see a picture of an actual compact tension specimen after failure. The strains collected during the tests by the back face strain gauge were fed into the Newman-Johnston compliance equation for back face strain in order to monitor the crack length with the number of cycles, and this can be done by using the strain data and calibrating this Newman-Johnston equation, in particular calibrating the Young modulus of the material in order to match the data coming from the crack gauges. So for both specimens, so specimen number 2 and specimen number 5, and this means for 2 different crack orientation, the Young modulus was the same, so it was 165,000 megapascals. And you can see here the 2 curves for the 2 specimens showing the matching between the different strain data. And at this point, we can finally see a comparison between the crack growth curves after pre-cracking for the 2 specimens. And we can see how the 2 curves are very near to each other. So the 2 specimens show a very similar behavior, both under the point of view of the crack growth behavior and under the point of view of the number of cycles to failure. So this means that in this case, or at least for this considered material, the crack orientation did not influence the fatigue life. So in conclusion, I showed you some very preliminary evaluations about the crack growth behavior of 17.4 pH stainless steel obtained by selective laser melting. Compact tension specimens were equipped with a back face strain gauge and 2 crack gauges and subjected to tension fatigue tests. And the data from both crack gauges and strain gauge were used for calibrating the Newman-Johnston back face compliance equation. And the metallographic analysis showed that there are different surface characteristics based on the considered plane, so based on the different orientation. And the 2 selected specimens showed that they have almost overlapping number of cycles to failure and crack growth behavior. And finally, near future activities will deal with carrying out experiments on the remaining specimens in a corrosive environment, so mainly in salted water. With this, I finish, and I really thank you for your attention.
Thank you.